Hi people, we are back, and in this video we are going to start implementing the interactivity for the player. If you remember, in the last video we created this animator with the multiple Boolean trees for idle and walking, and those are depending on these three variables: is moving, move x, and move y. Now what we need to do is to write a script that is going to read the interface, keyboard, mouse, game controller, and decide when to set these variables to start playing the proper animation for the character. Okay, so step one is for us to create a player controller. What I did here, I created in the assets folder a folder called input, and if you right click, come on Unity, if you right click, go to create and go to input actions, we can create our own input actions. I called mine player controls. And then you come here in the inspector and you set the generate C# class, you check this option and hit apply. So if you double click the player controls input action, you are going to get the input actions editor. And in here you can create your bindings, your maps for the actions, for the input actions that you want for the player. So the way the input action editor works is divided into three areas. The first area here is the action maps, and the second one is the action themselves, and the third one is the properties. So the action map is basically a view regarding a specific game controller. You can have as many game controllers, as many views as you want. Each view is going to be responsible for a one scope of the program. So let's say you have two players. One player is going to be each player is going to be its own game map. Or you can have multiple game maps for the same player. For instance, something that controls how the player interacts with the character in the game, and the second one how the player interacts with the application itself. So we are going to exercise this along the way, these cards and the next one. So in this example we are going now, it's very simple. So I only created one action map, I called it gameplay, and be careful with capitalization. And then I start working with the actions. So what kind of actions the player is allowed to perform whilst playing this action map. In this example, again, it's a very simple character, only two actions. One is called move, one is called attack. So whenever you create a new action, the first thing you need to define is what kind of data type you are manipulating whilst detecting inputs for that action. For instance, for the move action, we are moving our character on the screen, so or horizontal and vertically. So it's basically a 2D data. So if I select here the move action, you see that in the action properties, the action type is a value and the control type is a vector2. So what we are saying to Unity with this is that we need to get devices that can return values from that specific data type. And that's what I did here. I created three different bindings for the move action. One is called WSD or WASD keys. The second one I called 2D vector, and the third one is the left stick in the Xbox controller. All three of them are bindings that will return an XY value for us to process later in our C# script. So if you want to create new actions, you just click here the plus sign, and then you have the add up, down, left, right composite. That's the one I used here for these two, this one and this one. And as soon as you create these slots, you just click in any of these items, and you need to select what kind of binding. So what kind of device you are going to use to retrieve data for that specific variable. So in this example, for the up arrow, what I did here in the bindings, so I go into the drop down menu, I click listen, I push W, and I get here the W keyboard. And I repeat the process for all the other keys here, W, S, A, D, and up arrow, down arrow, left and right. For the left stick, the process is the same. As long as you have a game controller connected to your computer, if I repeat the process and click listen, I can push the control and I'm going to get that from my left stick Xbox controller, just like I did for the other ones. Okay, so this is for the move action. What I'm telling Unity is that either of these devices will return a XY value, a vector2 value, that will trigger a move action in my script later on. We need to program what to do whenever the move action is triggered. So in this case, we are going to move our character on the screen. Also changing the animation, like we are going to update these variables here in the animators tab based on this, so we can play the correct animation whilst also moving the character. And the same process we do for attack. We are not going to do that for now, but just for you to understand what we are planning in the future. The attack is not a vector2 variable, it's just a state variable. So you have an on-off kind of situation. Either I'm attacking or not, I push the button attack or not. So the action type is button. So again, I need bindings. So I have 3 bindings: the E key, the control key in the keyboard, so either or, and also the A button in the Xbox controller. So either of these will trigger an attack action in my C# script, and I need to program that script right now. Let's see how we are doing this. Okay, so what I did now, I created a C# script assigned to the player and open in Visual Studio. And let's see what we did. First thing, we need to use the input system, that package we just created the action maps and bindings and so whatnot. So this is a separate package in Unity. So we need to explicitly inform Unity that we are going to use functions from that package. So we have this using Unity Engine Data input system, semicolon, at the beginning of our script. And then we are going to be creating a bunch of variables that we'll be using throughout the script. The first thing is that the whole idea, we are going to use the interface to move our character around. So we need to define how fast our character is supposed to move on the screen. So I created a public variable, float speed, and by default I set a random number. We can, because the variable is public, you will be able to expose the variable in the inspector and then change the content later if you want our character to move faster or slower. So any value you put in here is just an initialization. You can change this later. So 5 is good as any. Okay, I need a reference to the actual input system we created. So remember, we called the player controls. So I created a variable called input actions, just because, could be any name you want. Also a reference to the animator. Remember that finite state machine that contains 2 blend trees, idle and walk. So we need a reference to that component because we are going to influence those parameters in the code and then change the animation. And also a direction, that's a vector2. Again, if you remember, one of the actions we create is called move, that is going to hold a variable for direction, a horizontal and vertical direction. So we need to store that. We don't need a variable for the attack button because it's a flag. It's an on-off kind of situation. So all we need is to trigger an event whenever the user pushes a button to attack, to play the animation for attack. We are not going there right now, but just for you guys to understand. So in the awake method, we initialize these variables. So we initialize the input action as a new instance of an object of player controls. And we grab the reference of the current animator that we have associated with the object. Remember, we are assuming that our C# script is at the same level as the animator script we created earlier. So this way the get component will work and we get a reference that we can access its method and manipulate. We call this an association. And the player control has this particularity that we can enable and disable the component. Whenever we want the player to be able to have access to the interface, we enable the access. Whenever we want the player to stop playing the component, we can disable the action map, and then the player will not have access to any interface to play the game. For instance, if the game is paused, we can disable the interface for grabbing actions. By default, we are going to enable as soon as the game starts, and if necessary, we can disable later. So it's mandatory that whenever you are using the new input system, we implement two methods, one called onEnable, one called onDisable. So, and what needs to be done whenever we are enabling and disabling the input. So in this case, what I'm doing here on enable, I enable the gameplay. Remember, the gameplay is our action map. So as soon as I enable the input system, I will enable the gameplay. So the move and attack functions, the move and attack actions will be accessible to the player. And then we need to decide what to do whenever one of the actions is triggered. In Unity, this is called performed. So remember, we call an action has the name move, and the other is attack. We are not going to implement the attack yet, but the move. So input actions.gameplay.move.performed tells me that the user pushed one of the bindings associated with the move action, and then we need to do something with that information. And what we do, we store that information in a variable. In this case, I created a variable called ctx, as in context. So what this variable does is that I can now read a value from this variable. If you remember, when we declare the input action move, we declare it of type value2 vector2. And now we have here in my method, in my class, I have an internal variable called direction. So basically what I'm saying, that direction is going to hold the content of that binding. So whatever I do with my game controller or the arrow keys or the WASD keys in the keyboard is going to be stored in this variable action all the times where the move action is performed. So if I push a key, the information is going to be stored in this variable. Later I can use this variable to animate my player on screen. And the same thing goes when the move action is cancelled, which means I release the key or the stick in the game controller. All I need to do is to reset the variable direction back to 0, because I'm not holding any key anymore. So in this case, I don't need to read anything else. So whenever I'm pressing a key that is binded to move, I'm going to store that information in the variable direction. Whenever I release the key, I reset that information, the direction variable, back to 0. Okay, so this is what I done in onEnable. And onDisable, all I need to do is to disable the entire gameplay at once, and that's pretty much it. Finally, I have implemented a method update. If you guys remember, the update method runs every frame of my animation. So whenever an input happens, I want to use that information to animate my character. So what I'm going to do here, I have two moments. The first moment where I physically animate my character on the screen, I slide them on the screen. And the second moment where I update the animator to play the proper animation to match the actual movement of the character. So let's go one by one. For me to slide my character on the screen, I do it in 3 steps. Step 1, I created a variable pause of type vector2, and I store the current position of my player on the screen. The parameter transform.position, it's literally, if I go back to my player, if I select the player here, you see you have here the transform component of the player. So what I'm getting is the position, this information here, XYZ position of the player, and I store this in a variable vector2. So remember that by default would be a vector3 because it has a XYZ, but since I'm storing vector2, what I'm telling Unity, you can ignore the Z component and focus only on X and Y. This is a 2D game, we don't care about the Z. So now that I have the current position of the player, it's time for me to update that position based on what the user is telling us. Remember, the variable direction contains the information towards which direction we want the character to move. Could be up, down, left, and right. So what I do, I take the direction, I multiply by the speed, that variable we created over there, and I multiply by time delta time. This is a little bit weird, I know. Why do I need to multiply by time delta time? And the reason for that is because I want to have my game running independently of the speed of the computer. So what happens is that back in the day, where the computers could not detect the speed, we would have that our game would be based on pixels on the screen, which means that a faster computer would move my character faster than a slower computer. And we don't want that. We want our games to run exactly the same speed, no matter how powerful the computer is. So by multiplying by time delta time, which means how many milliseconds it took from the last frame to the current one, we are telling Unity, if we are fast, we are going to move just a little bit. If you are slow, we are going to move a bigger chunk, and visually the character will always move at the same pace on the screen, and that pace is determined by the variable speed. So it's multiplying by time delta time, we are determining a small fraction of the speed that we need to move so that the character in the end moves the same amount of speed per frames in our game. And finally, we update that back to the position of the player, and that's it. So we grab the position of the player, we calculate the new position, and we update it back to the player on screen. Okay, so this will slide our character, our sprite on the screen, up, down, left, and right, based on the variable direction that comes from the inputs from the input actions. But that would not update the animations. If I only do this, what I get is a static frame moving up and down, left and right. And that's it's not what we want. We want to, whilst the character is sliding on the screen, I want also the character to be playing the walking animation facing the correct direction. That's what we created in the animator anyway. So I need to update those three parameters from the animator, and that's what we are doing. So is moving is a flag, true or false. So if my direction is not 0, that means the character is moving, therefore I need to play the walk animation. If the direction is equals 0, is moving is false, and so they are going to play the idle animation facing the proper direction, because I also going to send to the animator the current X and Y direction for the player to be facing when I'm moving the character. Okay, so this is slide the character on screen, this is animate the character in the proper direction.